Welcome to the beginning of your 5.1 Day 2 notes. I will do the first part of the notes on one video and the solving part probably on the second. So let's get to the combining of fractions here. Of course, when we're combining fractions, we have to have common denominators. So we need to create some common denominators here. Looks like these 1 over secant x minus 1 and the secant of x plus 1, they need each other. So we need top and bottom are what they're affecting. So the secant of x plus 1 on this one top and bottom. Secant of x plus 1. And this one means the secant of x minus 1. Now we can figure out our denominator is the product of those two. So the secant of x minus 1 times the secant of x plus 1. Sometimes the productive thing to do is to multiply those out. Sometimes it's to leave it back. It remains to be seen which is best in this situation. So we'll just leave it like that for now. In my numerator, I have the secant of x plus 1. Now notice right here I have minus 1 times these. So I'm basically adding negative 1 times these two. So I have minus the secant of x and a plus 1. Looking at the numerator then, I have my secant minus secant down to 0, and I have 1 plus 1 is 2. And down here, well, I've got the secant squared of x minus 1. I've multiplied those together. Notice that that comes from doing something like a plus b times a minus b. When we multiply that out, we end up with a difference of squares. These are conjugates, exactly the same, but one is plus, one is minus. That ends up being a squared minus b squared. And that's exactly what we have here, secant squared of x minus 1. And that looks really familiar. Secant squared of x, manipulating a Pythagorean identity, is simply tangent squared of x. And if I've got a tangent squared in the denominator, well, then that's the cotangent. So it's 2 times the cotangent squared of x. Moving on to the next one. Now we've got two different denominators together. One looks like they're going to need each other, so I'm going to multiply by 1 minus the cosine of x here and here. And on my first fraction, they both need a sine top and bottom. Now when we do this, we want to make sure that we're treating it like this. The factors need to be treated as factors. So let's go ahead and multiply these out. And doing so gets us in the numerator sine squared of x. Now let's multiply these two together. I'm going to go ahead and multiply them out and distribute all that out. So that would be 1 minus 2 cosine of x's plus cosine squared of x. Again, this one is like doing a minus b quantity squared, a minus b times itself. And that always ends up being a squared minus 2ab plus b squared, which is exactly the pattern that we have here. Look at the coefficients, look at the squared terms, they are the same. Just as different. Instead of a and b, we have 1 and cosine. Right, now our denominator is sine of x cosine. I'm going to leave it like that for now, just in case one of those could simplify. It's a nice. Alright, now up here, I have sine squared of x, and I have a cosine squared of x added together, and I know that those two together with the Pythagorean identity is 1. It's simply 1 with these two together. So in the numerator, I have 1 from those two, and another 1 from those. So altogether, I have 2 minus 2 cosine of x in my numerator. So my sine, and my 1 minus cosine of x in the denominator. And let's read that. So if I were to, maybe we should factor out a 2. So that would be 1 minus the cosine of x. And I'm putting that over sine. And my 1 minus cosine. And because these are factored, I can simplify that to 1. They divide to 1. And now I've got 2 over the sine of x. And when I have a sine in the denominator, that means I'm really dealing with a cosecant. So this is 2 times the cosecant of x. And that's on a single trig function, and as simple as it can get. Okay, now factoring, there's a couple of things that we want to remember. Primarily, when we have something kind of like what we just saw with the fractions, and common denominators, when we square an item, xa squared plus 2ab plus b squared. So what we're going to be finding is something like this, and we're going to factor it. We also may find when we have a difference of squares that we can factor into a minus b times a plus b. So we'll be looking for those patterns and applying them then with our cosines and sines and whatever else we may have. Okay, this first one here, I do not like the fact that I have sine and cosine mixed. Not at all. So I'm going to replace the cosine squared because I have a Pythagorean identity that links the cosine squared to a sine squared, which then will agree with this sine and I can do something with it. So I'm going to leave this as the sine of x, and that part right there I'm going to replace with its equivalent 1 minus the cosine squared of x. Bring that 1 minus the cosine and replace the sine. Awesome. Minus 1. So then I can regroup this a little bit. 1 and negative 1, that's 0. So I have the sine of x minus the sine squared of x. Factoring out sine of x, I get 1 minus the sine of x. And we're going to call that factored, because it's this times this. Now, when is this going to come in handy? When we're solving equations, which you will see on the back side of your note sheet. Okay, leave that in factored form just like that. Moving on to the next one. I've got a cosecant down here in my denominator. Well, that could go back up into the numerator as a sine. So we have the sine squared of x plus 2 times the sine of x plus 1. Now take a really good look at the pattern that you have here, and the pattern that you see should remind you of what we have here. We have a square term on each end, squared term on each end, and then we'll have a double here. So this will factor into something really nice, like you see at the top of the screen. This is simply the sine of x plus 1 times the sine of x plus 1, or you can write it as the sine of x plus 1 quantity squared. And again, it's factored, something times itself. Okay, now let's simplify this into a single trig function. I'm getting my clues here by having a secant in the denominator and a tangent. I know that those are related with the Pythagorean identity, particularly with the square. So I can replace tangent squared with, well, let's take a look. It's 1 plus tangent squared of x that equals the secant squared. I don't have the 1, so if I subtract the 1, that tells me that the tangent squared is the secant squared of x minus 1. So I'm going to go take this and replace it with the secant squared of x minus 1, and that's over the secant of x plus 1. Look at it carefully, that is a difference of x squared. So the numerator factors into the secant of x plus 1 times the secant of x minus 1 all over the secant of x plus 1. This is a thing, and it is a factor that simplifies with that identical factor in the numerator. So this is very simply the secant of x minus 1. Now it's written as a single trig function.